Good day everyone, I am Rhea May Quijano, and today we will tackle about principal roots and irrational numbers. Objectives. First, we will define principal root. Second, we will describe principal roots and tell whether they are rational or irrational. And the third one is we will determine between what two integers the square root of a number lie. These are the definition of principal root, perfect square, rational number, and irrational number. First, principal root. It is a number which produces a specific quantity when multiplied by itself. It is a positive nth root of a number. A perfect square is the square of a rational number. Then rational number is a number that can be expressed in the form AB, where A and B are integers, and B is not equal to 0. Irrational number is a number whose decimal representation is neither terminating nor repeating. This number cannot be expressed as a quotient of integers. Earlier, you have tried to get the equivalent of each of the following using a scientific calculator. You have also known that the equivalent value is called principal root. So I have some example here. First, square root of 36 is equals to 6. Then square root of 64 is equals to 8. Square root of 2 is equals to 1.4. Square root of 50 is equals to 7. Square root of 81 is equals to 9. Square root of 75 is equals to 8.6 or 8.7. Then, notice that some principal roots are whole numbers while some are decimal numbers. That means, when a principal root is a whole number or fraction, then the principal root is described as rational. Then the second one is when a principal root is a non-terminating or non-repeating decimal number, then the principal root is described as irrational. To determine whether a principal root is rational or irrational, we need to get first the principal root of a number. We can use a scientific calculator to get exact principal root of a certain number and tell if it is rational or irrational. We can also use the concept of perfect square to separate rational from irrational principal root. Consider the given below. I have some example here. This one and this one. So, given 1 times 1 is equals to product of 1. Then 2 times 2, product of 4. 3 times 3, product of 9. 4 times 4, product of 16. And 5 times 5, product of 25. So, next, perfect square. All the direct products are considered as perfect square. So, what is perfect squares? Perfect squares are the numbers that have rational numbers as principal roots. Moreover, taking the principal root of a number is like doing the reverse operation of squaring a number. Those, number 1, when 1 times 1 is equals to 1, then square root of 1 is equals to 1. Now, since we have extracted a rational number, which is 1, therefore we can say that the principal root of 1 is rational number. When 2 times 2 is equals to 4, then square root of 4 is equals to 2. Now, since we have extracted a rational number which is 2, therefore we can say the principal root of square root of 4 is a rational number. Then, when 3 times 3 is equals to 9, then square root of 9 is equals to 3. Now, since we have extracted a rational number, which is 3, therefore, we can say that the principal root of square root of 9 is irrational. Also, when 4 over 5 times 4 over 5 is equals to 16 over 25, then square root of 16 over 25 is equals to 4 over 5. Now, since we have extracted a rational number which is 4 over 5, therefore we can say that the principal root of 16 over 25 is rational. Hence, the principal root of all perfect squares such as but not limited to square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, and so on, are rational. On the other hand, when a number is not a perfect square, then its principal root is rational. We have some example here. Number 1. Square root of 2. Can you think of any number that when multiplied by itself will give an answer of 2? None. We can say then that 2 is not a perfect square. Therefore, the principal root of square root of 2 is irrational. Then number 2. Square root of 15. Can you think of any number that when multiplied by itself will give an answer of 15? We can say then that 15 is not a perfect square. Therefore, the principal root of square root of 15 is irrational. Number 3. Square root of 3 over 10. Can you think of any number that when multiplied by itself will give an answer of 3 over 10? None. We can say then that 3 over 10 is not a perfect square. Therefore, the principal root of square root of 3 over 10 is irrational. If a principal root is a rational number, the easiest way you can do is to determine between what two integers the square root of a number lie. Now, let us start with our discussion on how to determine the two consecutive integers where the square root of a number lie. Examples. The principal root of a radicals below are between two integers. Find the two closest integers. A. Square root of 12. B. Square root of 18. C. Square root of 40. D. Square root of 175. The solution. Then the correct answer is letter A. So think of two consecutive perfect square integers where 12 is in between of them. Number 8, number 9, number 10, number 11, 12, 13, 14, 15, 16. So, we have 9 and 16. Take the square root of this number. Since the principal root of square root of 9 is 3, while the principal root of square root of 16 is 4, thus square root of 12 is between 3 and 4. Letter B, square root of 18. Think two consecutive perfect square integers where 18 is in between of them. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So, we have 16 and 25. Take the square root of this number since the principal root of square root of 16 is 4, while the principal root of square root of 25 is 5. Those square root of 18 is between 4 and 5. Letter C, square root of 40. Think of two consecutive perfect square integers where 40 is in between of them. 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. So we have 36 and 49. Take the square roots of these numbers since the principal root of square root of 36 is 6, while the principal root of square root of 49 is 7. Those square root of 40 is between 6 and 7. Then the last one is square root of 175. Think of two consecutive perfect square integers where 175 is in between of them. 168, 169, 170, 171, 172, 173, 174, 175, 176, and so on to 196. So we have 169 and 196. Take the square roots of these numbers since the principal root of 169 is 13, while the principal root of square root of 196 is 14. Those square root of 175 is between 13 and 14. That's all. Thank you po.